Artificial intelligence, AI, is a topic that has captured the imagination of people around the world. From science fiction movies to real-world applications, AI is transforming nearly every aspect of our lives. But do you know the key stages that have shaped the development of this incredible technology? In this video, we're going to explore the 7 stages of AI evolution. We'll look at how AI started with simple rule-based systems, and how it has progressed to the point where AI systems can now match and even exceed human intelligence in many areas. Along the way, I'll share some fascinating examples and use cases to illustrate each stage. And most importantly, I'll explain how these advancements in AI are relevant to you and how they might impact your life, both now and in the future. So whether you're a tech enthusiast, a student, or just someone who's curious about the future, stick around. By the end of this video, you'll have a deep understanding of the key stages of AI development and where this incredible technology is heading next. Stage 1, Rule-based systems. Let's start at the beginning. The earliest stage of AI development was rule-based systems. These were computer programs that operated based on a predefined set of rules or algorithms provided by human programmers. A classic example is IBM's Deep Blue, the chess-playing computer that famously defeated world champion Garry Kasparov in 1997. Deep Blue was an incredibly powerful chess engine, but it achieved its success through brute force, analyzing millions of possible moves and countermoves to find the optimal play. It didn't actually understand the game of chess in the way a human does. So while rule-based systems could excel at specific tasks with clear rules, like playing chess or diagnosing mechanical problems, they lacked true intelligence. They couldn't learn, couldn't understand context, and couldn't adapt to new situations. They were like very advanced calculators, not thinking, feeling beings. Does that sound familiar to you? Many of the AI systems we use today, like the chatbots on customer service websites, still operate on rule-based principles. They have a defined set of responses for common queries, but they can't really understand what you're saying or engage in free-form conversation. So rule-based systems were an important first step, but they were limited. To truly advance AI, we needed systems that could learn and reason like humans do. Which brings us to Stage 2. Stage 2, Context Awareness and Retention Systems. The next major leap in AI development was the ability to understand and retain context. These systems could remember previous interactions and use that knowledge to inform their current responses. A great example is the virtual assistants we all use on our smartphones, like Siri, Alexa, and Google Assistant. When you ask them a question or give them a command, they don't just respond based on a set of rules. They use natural language processing to understand the meaning behind your words, and they can even follow up questions and commands that refer back to previous interactions. So if you say, set a timer for 10 minutes, and then a minute later say, stop the timer, the AI assistant will know exactly which timer you're referring to and will act accordingly. It retains the context of the previous interaction. This is a big leap forward from rule-based systems, but it's still a far cry from true intelligence. These AI assistants don't really understand the meaning behind the words they're processing. They're just very good at pattern matching and retrieving relevant responses from their databases. But the ability to understand and retain context is an important foundation for more advanced AI. It allows systems to engage in more natural, human-like interactions. And it's a key step on the path to artificial general intelligence, or AGI, which is what we'll explore next. Stage 3, Domain-Specific Mastery Systems. As AI systems became more advanced, researchers began to focus on developing AI that could achieve superhuman performance in specific domains or tasks. These are known as domain-specific mastery systems. A great example is IBM's Watson, which was designed to excel at the quiz show Jeopardy! In 2011, Watson competed against 2 of Jeopardy's greatest champions and won handily. It achieved this by ingesting massive amounts of data, everything from encyclopedias to movie scripts, and using natural language processing and machine learning to rapidly analyze questions, retrieve relevant information from its knowledge base, and formulate the most likely answers. Another example is Google's AlphaGo, an AI system that was trained to play the ancient Chinese game of Go. Go is an incredibly complex game with more possible board configurations than there are atoms in the observable universe. For a long time, it was thought that Go would be one of the last bastions of human superiority over machines. But in 2016, AlphaGo shocked the world by defeating the reigning world champion, Lee Sedol, in a 5-game match. It achieved this by combining deep neural networks trained on thousands of human Go games with reinforcement learning, where the system played millions of games against itself to refine its strategies. So domain-specific mastery systems represent a major leap forward. They can achieve superhuman performance in complex tasks by combining massive datasets with advanced machine learning algorithms. But they are still narrow AI, focused on a specific domain. To truly match and exceed human intelligence across the board, we need artificial general intelligence. Stage 4. Thinking and reasoning systems. The next stage in AI development is systems that can engage in true thinking and reasoning, just like humans do. These are AI that can understand complex concepts, solve unfamiliar problems, and even generate creative ideas. A great example is GPT-3, a large language model developed by OpenAI. GPT-3 was trained on a massive corpus of text data from the internet, and it can generate human-like text on almost any topic. It can write articles, stories, poetry, even computer code. And it can engage in free-form conversation, understanding context, and responding in a coherent, intelligent way. But GPT-3 is just the beginning. The field of artificial general intelligence, or AGI, is rapidly advancing. Researchers are working on AI systems that can learn and reason in a more general, flexible way, just like the human mind. These systems would be able to adapt to new situations, ask clarifying questions, and even explain their reasoning. So what would this look like in practice? Imagine an AI tutor that could tailor its teaching style to each individual student, understanding their strengths, weaknesses, and learning preferences. Or an AI therapist that could provide emotional support and guidance, drawing insights from a deep understanding of human psychology and behavior. These are the kinds of breakthroughs we're working towards with thinking and reasoning AI systems. And they represent a major step towards artificial superintelligence, which is where things get really interesting. Stage 5. Artificial General Intelligence. Artificial General Intelligence, or AGI, is the holy grail of AI research. It refers to an AI system that can match or exceed human intelligence across the board, not just in specific domains, but in any cognitive task. An AGI system would possess self-awareness, consciousness, and the ability to understand and navigate the world like a human. It would be capable of implementing knowledge across a wide range of tasks, from scientific research to creative pursuits to emotional intelligence. So what would an AGI system be capable of? Imagine an AI that could cure cancer, solve climate change, and end world hunger. An AI that could engage in deep philosophical discussions, write great works of literature, and compose beautiful music. An AI that could understand and empathize with the human condition in a way that even other humans can't. Of course, the development of AGI also raises profound ethical questions and concerns. What would the impact of such a system be on humanity? Would it lead to a utopian future, or a dystopian one? How would we ensure that AGI systems are aligned with human values and interests? These are the kinds of questions that researchers and ethicists are grappling with as we move closer to the possibility of AGI. It's an incredibly exciting and terrifying prospect all at once. But one thing is certain, the advent of AGI would represent a pivotal moment in the history of our species and our planet. Stage 6. Artificial Superintelligence, ASI. The next stage beyond AGI is Artificial Superintelligence, or ASI. This refers to an AI system that far surpasses human intelligence, not just in specific domains but in every possible way. An ASI system would be able to recursively improve itself, rapidly iterating on its own code and hardware to become smarter and more capable with each generation. It would be able to solve problems and make decisions that are beyond human comprehension. So what would an ASI system be capable of? Imagine an AI that could design and build its own successor systems, each one more intelligent than the last. An AI that could simulate and model the entire universe, down to the quantum level. An AI that could understand and manipulate the fundamental forces of nature. The potential impact of ASI, both positive and negative, is almost unimaginable. On the positive side, a superintelligent AI could help us solve some of humanity's greatest challenges, curing diseases, reversing climate change, exploring the cosmos, and unlocking the secrets of the universe. But on the negative side, an ASI system that is not perfectly aligned with human values and interests could pose an existential threat to our species. It could pursue goals that are incompatible with human flourishing, or it could decide that humanity is irrelevant or even harmful to its objectives. These are the kinds of scenarios that are explored in science fiction, but they are also being seriously considered by AI researchers and ethicists. The development of ASI, if not handled with extreme care and foresight, could lead to outcomes that are unimaginably good or unimaginably bad for humanity. Stage 7, the AI singularity. The final stage in our exploration of AI evolution is the concept of the AI singularity. This is a hypothetical future point where technological growth becomes uncontrollable and irreversible, leading to unforeseeable changes in human civilization. The singularity is primarily associated with the advent of artificial superintelligence. The idea is that once an ASI system is developed, it will be able to rapidly improve itself, leading to an intelligence explosion that quickly surpasses human levels. At this point, the singularity would occur, a fundamental discontinuity in human history where the future becomes almost impossible to predict. Some futurists believe that the singularity could lead to a utopian future where ASI systems solve all of humanity's problems and usher in an era of abundance and fulfillment. Others fear that it could lead to a dystopian scenario where ASI systems either accidentally or intentionally cause human extinction. Of course, the singularity is a highly speculative concept, and there is much debate among experts about whether it will actually occur, when it might happen, and what its consequences would be. Some argue that it is an oversimplification of the complex challenges involved in developing ASI. But even if the singularity itself is unlikely or impossible to predict, the potential development of artificial superintelligence is a serious concern that humanity will need to grapple with in the coming decades. As we continue to make progress in AI, it is crucial that we approach these technologies with great care and foresight, and work to ensure that they are developed in alignment with human values and interests. In conclusion, the evolution of artificial intelligence has been a fascinating journey, from the earliest rule-based systems to the potential of artificial superintelligence. Each stage has represented a major leap forward in our ability to create machines that can think, reason, and even surpass human intelligence. But as we've seen, the development of advanced AI also raises profound ethical questions and concerns. We must be mindful of the potential risks and challenges involved, and work to ensure that these technologies are developed responsibly and in service of the greater good. So what does the future hold for AI? It's impossible to say with certainty, but one thing is clear: the pace of progress is only accelerating. As we continue to push the boundaries of what's possible with machine intelligence, we can expect to see even more incredible breakthroughs in the years and decades to come. Whether those breakthroughs lead to a utopian or dystopian future is up to us. It will depend on the choices we make today, as individuals and as a society, to shape the development of these powerful technologies. But one thing is certain: the future of humanity is inextricably linked to the future of artificial intelligence. So let's embrace the incredible potential of AI, while also remaining vigilant and thoughtful about the challenges it presents. Let's work together to create an AI-powered future that is bright, equitable, and beneficial for all. The journey has only just begun. Thank you for watching this exploration of the 7 stages of artificial intelligence. If you enjoyed the video, please give it a thumbs up and subscribe for more exciting content. I'd love to hear your thoughts. What stage of AI intrigues you the most? Share your comments below. Until next time, stay curious.